Okay, good. Okay, so we're doing solving linear inequalities, and what an inequality is greater than, less than. What direction is less than?
Yeah.
Possibly.
Okay, or what else?
Left.
Yes, so greater than is what direction?
Right.
Or right, yes, very good. Okay, let's look at this first example. This is an ordered pair, okay? So we have an x and y. All you're doing on these first examples is taking the x and y, plugging it into the inequality, and seeing whether it's true or not, okay? So y becomes 3 and x becomes 7. So I replace the y with 3 and the x is 7 and I solve it. 7 minus 1 is 6. Then say this to yourself. 3 is less than 6. Is that a true statement? Yes. So this one's okay. 7 and 3 is a solution of this one. Okay? Second example, exactly the same. There's just a little more going on here. We have an x of 4 and a y of 5. We're gonna put it into our my glasses must be dirty. Okay, so x is 4, y is 5. It's because you can hear Naomi when I'm trying to talk. So 5 in here, 3 in here. Remember, this x becomes parentheses, right? So we input the 4 into parentheses and then solve it, order of operations. 3 times 4 is 12, bring down to 2. 12 plus 2 is 14. Then we say this to ourselves, 5 is greater than 14. Is that true?
No.
No. So we put an x. 4 or 5 is not a solution of this inequality. Make sense?
Sure.
Okay. Next one. We start to get into, we don't have an ordered pair, right?
Sure.
So we want to know if an ordered pair solves for it, okay? So we're going to take this equation and essentially we're going to put in an ordered pair of 0, 0. So our x is going to be 0 and our y is going to be 0, okay? So I'm going to replace the y, I'm going to replace the x with 0. So I'm going to multiply. 3 times 0, which is 0, plus 4, it's 4. Just bring down the 0. 0 is less than 4. Yes, that's a true statement. We're not done yet, okay? We're gonna put on the graph 0, 0. Is it in the shaded area? Yeah, it is, because this is less than, right? So less than shades down. So let me cover this in case you haven't had this before. Less than, the line is dashed, okay? If it's less than or equal to or greater than or equal to with a little line underneath it, the line is solid. Do we understand? Okay, greater than is what direction again? Yep, and less than is what? Good. Okay, this one's less than, right? So we're dashed line, shaded down. Once we put the ordered pair in, because we weren't given an ordered pair, anytime we're not given an ordered pair, we plug in 0, 0. We put it on the graph. We see it's within the shaded area. 0, 0 is a solution. It's a true statement. It works. Do we understand? Do you want me to go through it one more time? Okay. Linear equation, right? It's in slow form, correct? Yeah. So we're going to take this and we're going to replace x with 0 and y with 0. So we're going to use an ordered pair of 0, 0. I always love my students come in. Get excited. Oh, jeez. Okay, back to this. So 0, 0, and we go ahead and solve for it, okay? Multiply 0, bring down the 4, because 0 times anything is what, Naomi? Your time to shine? It's nothing, right? It's nothing, so we just bring down the 4. Once we put the ordered pair in there, we go ahead and graph it out. It's less than, we know it's heading down. How do we graph this? Right? We go to 4, the b, right? And our rise and run is up 3 over 1. So we're going to graph it here. We're going to go up 3 over 1. There's our line. It's dashed. It's less than. Shaded down. We use 0, 0. It's within the shaded area. Now, don't get confused. I just didn't shade in here, but it's everything down is shaded. Are we good on this?
Sure.
Okay, let's go to the next one. No ordered pair, correct? So what am I going to use on this one?
0, 0.
Yes. Can I work with this?
Possibly.
What do I need to do to this?
Move the y from this side.
Correct. Well, give me some vocab.
Subtract 3x.
What do we call this? What do we need to get this into?
The slope form.
Slope form, yeah. The reason why we needed a slope form is we're trying to find out what inequality works, okay? So we need to get in slope form so we can graph it out, right? So we're going to take this equation, and how am I going to start it, Adrian?
Minus 3x.
Yes, I want the 2y by itself, right? So I'm going to subtract 3x from both sides, Gus. Okay, so this cancels out, gets the 2 by itself, bring down the 2. Can I combine these?
No.
I can't because of the x, right? They're not like each other. So it's 2y, bring down my symbol, negative 3x plus 6. Now we're going to divide by 2. Is there anything new here so far?
No.
Nothing. Divide by 2, divide this side by 2. Now, this is the one thing that's different. When you're dealing with an inequality, okay, and everyone needs to hear me this, when I say this, what happens when you have a negative fraction you go to graph out?
It goes to the left.
Yes. When it comes to an inequality, if there's a negative on the top or a negative on the bottom, and a positive on the top or a positive on the bottom, you leave it the way it is. Okay? So essentially what am I telling you? When it comes to an inequality, you never go to the left. Are we clear?
Sure.
Let's talk about this. So this is 3 over 2, right? That means this is negative 3 over positive 2, right? Because what is this 2?
Positive.
Positive, okay? And 6 divided by 2 is what?
2 over 3.
Okay? So we can graph this out, right? So when we go to graph this out, we're going to go to 3 on the graph. We're going to go down 3, and we're going to go over 2, to the right. Okay? Because we treat this as a positive. Now let me explain why. When it comes to an inequality, that symbol matters. If we were to change the polarity of this, where it was negative, negative, and we turned it positive, or we made it negative and we went to the right, we just changed the entire inequality of the graph. Okay? So, a negative stays a negative and a positive stays a positive in the rise and run. Okay? You still follow the same rules when it comes to the B. Are we clear? 3. Down 3, over 2. Graph it out. Now I do want to talk about this for a minute. Let's say we were to make this negative. Negative 3 over 2 since it was a positive 2, right? Well, we'd still start at 3. What direction would the graph go up if it wasn't going down?
Left. Down, left.
If it wasn't going down, it'd be going up, right?
Oh, yeah.
Because the rise and run is going to be exactly opposite, right? So down 3 over 1, up 3 over 1, right? Okay, so after I graph this line, what direction is this going? What is this called?
Greater than or equal.
Very good, greater than or equal to. So we know this line is solid, okay? We went and graphed it out. We started at 3. We went down 2 and over 2. Solid line, greater than, shaded up. Do we truly understand why it's greater than? Is this, if this were the point on the graph, is this greater than this right here? Yes, because these are negatives and these are positives, okay? So, after we have this in slope form, after we graph it out and shade it out, we're going to go check it, okay? And how we check it, we take it in slope form, okay? So this same thing, I'm going to rewrite it, and I'm going to plug in 0, 0 for my ordered pair. So I use 0 for y, I use 0 for x. What is a fraction times a 0, Naomi? Time to shine. What's anything times 0? Fabian, go. Anything times 0.
0.
We'll wait for you.
Oh, 0.
Okay, good. Even a million? Yeah. 0 of anything is always 0. Okay, so none of this matters, right? We just bring down the 3. So we bring down the 0, we bring down the symbol, we bring down the 3, and we say this to ourselves. 0 is greater than or equal to 3. Is that true? No. 3 is greater, right? So when we go to the graph, 0, 0 on the graph, because this is the order pair we used, our shading went up. Is it in the shaded area? No. So this 0, 0, 0 would not be a solution within this inequality. Okay? Are we good? Okay, let's go to F. Anything really special on this problem?
No.
No. Does this look strange?
Yeah, no.
It just overtakes it, right? Yeah, because it's positive times a negative, it turns to negative. We can graph this out. We go down to negative 2 on the graph, we go up 5 over 1. There's our line. It's equal to line is solid. Line is solid. Greater than is what direction in this case? Greater than from where we're at here? Because this, when it gets steeper, it gets confusing, right? But remember, if it's going down, it's less than, right? So it always has to go up. But it looks strange, and our brains have a hard time comprehending it when the line starts to get steeper, right? But think of it this way. We know that up is greater than, right? So at some point, depending on that slope, this still needs to be going up, no matter what. If we shaded it down this way, this is dealing with all those negatives. Do we see that?
Yeah.
Can you guys relate with the fact that your brain plays tricks with you on this one? Amazing. Okay, so we're going to check it now, right? So this is already in slope form. We're going to replace 0, 0 for our x. Fabian just told us that 5 times 0 is 0, right? So we just bring down to -2, and then we answer this question. 0 is greater than or equal to -2. Is that true? Yes. Yeah, because -2 is less than. You would rather have $0 than owe someone $2. So we go graph the 0, 0. Notice it's in the shaded area. That solution works. It's fine. Good so far? Minnie? Solid?
Sure.
Okay. E. Nothing really special with E. Already in slope form, right? So we're going to graph it out. We're going to go to 2. We're down 1 over 3. Remember, everything on inequality is to the right. Okay? So down 1 over 3. This line is not equal to, so it's dashed. It's less than, shaded down. We're going to plug in 0, 0 into slope form. So x becomes 0, y becomes 0. We bring down this 2, bring down the 0. Ask yourselves, is 0 less than 2? Yes, 0 is less than 2. We graph the 0, 0. It's in the shaded area. This checks out. You see the repetition now?
Sure.
Nothing special. Okay, let's talk about this one. Just because it can be a little bit confusing. Y equals none. Okay? What is y? What is y at the end of the day? The y-axis, correct? So if you're given a problem that says x is greater than or equal to -2, that means there's no y. Okay? So in slope form, all we have is this. We go to x, -2, the line's straight up and down. Okay? Straight up and down means no slope. It didn't say undefined. Undefined would be this way, horizontally. Horizontal. Okay? It's going up and down from here. We go ahead and graph that out. Now, which way is greater than? Well, if this is -2 and 0 is heading this way, what's greater than? To the right, correct? So same thing. We go ahead and shade in here. Now, our x is 0, right? No real reason to check this. 0 less than -2. We know it. We know it's going to work within there, right? So it's a solution that will work. Okay, any questions on this? Is there any that I need to go over? I have a couple questions. Greater than or equal to, what does the line need to look like on the graph?
Up or down?
Besides that, what does the line need to look like?
Solid.
Very good. What if it's not equal to? What if it's just greater than? Dashed, okay? And greater than is headed what direction? And less than is what direction? Or what else?
Left.
Yes, left and right. Okay. Remember, you have to put things in slope form. Okay? So let's look at the do now. You want to put this in slope form. Okay? After you do it, go ahead and graph it out. Graph the inequality. Okay? Is this one dashed or is this one solid?
Dash.
Okay? We don't know. Do we know what direction it's going? Yeah, we know because it's greater than. Okay? This one's greater than. This one is what? Greater than or equal to. So this is the only one that's solid, right? Is this one in slope form?
Yes.
This one's in slope form. So all you're doing, getting these two in slope form, using the order pair 0, 0, plug it in, check it, graph it out, graph out your 0, 0, and tell me whether it's a solution or not. Any questions? Slope form, graph, check, shade it in. Okay? All right. Gustavo, make miracles happen, sir. Barbara, Gus, go next door.